So differentiation today will strongly recommend that you should know all the formulas first of all. All right, then only start with the thing. So the first one, I'll give you hints. It's not that I'm going to solve the whole thing, but wherever is required, I'll give you hint like y equals to cos x plus sin x upon cos x minus sin x. Y is equals to cos x plus sin x upon cos x minus sin x, and you see that you have to prove dy by dx is sec square. Huh? So whose differentiation is sec square? Think backwards. Whose differentiation is sec square? Tan. So what I do, I divide the numerator and denominator each term by cos x. We get 1 plus tan x upon 1 minus tan x. Now you know from class 11th knowledge 1 plus tan x upon 1 minus tan x is nothing but tan 45 plus x using tan a plus b formula. Hence dy by dx will be equal to sec square pi by 4 plus x. Hence proved. Question number 2, we can do a lot of things, but the best way what I feel is, you see 1 plus sin x, you can break sin x as 2 sin x by 2 cos x by 2. I have explained this concept in inverse trigonometry as well, if you recall. And because this is looking like 2ab, so what I'll do, I'll change this one as cos square x by 2 plus sin square x by 2. Why? Because this is looking like 2ab. If I get a square plus b square, which is making it 1 anyway, so 1 can be replaced by cos square theta plus sin square theta. So we can generate a formula here. You have to show all the steps in the exam. This becomes cos x by 2 plus sin x by 2 whole square. Fine. So you see where I am, like what I want to do. I want to put cos x by 2 plus sin x by 2 whole square here so that the root goes. So you get cos plus sin plus cos minus sin. Then again same thing, we'll end up getting cot x by 2, and that when differentiated will be minus half cos x square x by 2. So see, it's coming directly. So what we do now, we will replace 1 minus sin x as cos x by 2 minus sin x by 2 whole square. Replace these values there and we'll get y is equals to cot x by 2 at the end. So differentiate that. That will be dy by dx equals to cot. So negative differentiation of cot is minus cosec square x by 2 here because angle is x by 2, and x by 2 when differentiated because of chain rule will be half. Hence the answer. Next sum, third, sine inverse x under root 1 minus x minus root x under root 1 minus x square. You can do, like if you see this meticulously, this is nothing but root x square if you see. So that this is y equals to sine inverse x under root of 1 minus root x square minus root x under root of 1 minus x square. So see, if you see this, this is what? This is sine inverse. You can recall a formula. If you see this, it's sine inverse x under root 1 minus y square minus y under root 1 minus x square. Put x equals to sine theta, and as if like this is y, this is z or something else, like you can take any variable. So root x is something sine alpha. Don't take root sine theta. That's the trick here. If you say how x can be, sine theta, then root x is root sine theta. So fine, root sine theta can correspond to something sine alpha. For some any angle alpha, it is possible, isn't it? So same way, we can take different things. Why? Because the question will change to sine inverse x, which is sine theta, and under root of 1 minus sine square alpha. So cos alpha minus root x, that is sine alpha and cos theta. So now this becomes sine inverse sine theta minus alpha. Sine inverse sine nullifies, we get theta minus alpha. But what is theta? Theta is sine inverse x. Alpha is sine inverse root x. Okay. From this x equals to sine theta, theta is sine inverse x, and from this root x equals to sine alpha, alpha is sine inverse root x. So we substitute now. This is good step to get differentiated. So dy by dx will be 1 upon under root of 1 minus x square, and minus 1 upon under root of 1 minus root x square, which is x. But because root x, you have to do chain rule. Root x when differentiated is 1 upon 2 root x. So you multiply this, keeping 2 outside, and that will be your final answer. So next question is fourth. Here you put x square is equals to cos 2 theta and use 1 plus cos 2 theta. What is 1 plus cos 2 theta? Learn the formulas I am telling you. 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sine square theta. Substitute these values here and you'll see something, it will convert into this one, this kind of question number 1. Try. And if you don't get, ask me in the class, but you'll get it now. Everything is told already. Fifth, same as the second sum. That's the best part of this chapter, You're done with something that helps you in the forthcoming sums as well. Knowing inverse trigonometry, I think almost like 40% of differentiation, because many sums are based on those facts only. Here, you see this question, fifth I told you, is based on second. So just convert the way I told you and you'll get the answer. Alright. Sixth. Next question is sixth. In this, if you recall, put x equals to tan theta. I told you that wherever root 1 plus x square is there, put x as tan theta. Where there is a denominator. If the denominator is not present, like in the next one, 7th, there is no denominator. There you put x equals to cot theta. Okay, and you will get the result. But in 6th, it is differentiation of y with respect to tan inverse x is required. Okay, so you have to say, see, theta is your tan inverse x only. Okay, so that means your answer is dy by d theta required, not dy by dx. Understood? Because we need to find out with respect to theta only, with respect to tan inverse x. So put x as tan theta and find dy by d theta for 6th. For 7th, put x as cot theta, I told you already. For 8th, guess what you have to put x as? Yes, correct. Put x as tan theta only, because 1 plus x square is the indicator that you should put x as tan theta. 1 minus x square is the indicator you should put sin theta. Both are present, 1 plus x square, 1 minus x square, you put x square as cos 2 theta. I already told all these things earlier also. 9th sum is a superb sum, it's very important sum also. So I'll solve this fully for you. The question is 1 minus x square whole under root plus 1 minus y square whole under root is equals to a times x minus y. So we'll put x equals to sine theta. I told you. When root 1 minus x square tells me that I should put x as sine theta. But there is 1 minus y square also. So that's why we'll put y equals to something. Sine alpha or something. Put sine or cos. You can't put two different things. It will result in a very unorganized and non-symmetric things then. So put 1 minus x square like 1 minus sine square theta. We get cos theta. Show your calculations. I am doing it directly. Cos alpha is equals to a sine theta minus sine alpha. Cos c plus cos d is 2 cos c plus d by 2 cos c minus d by 2 a into 2 sine c minus d by 2 cos c plus d by 2. Okay, if you don't know these formulas, please learn them. It's too late now, otherwise I'll be helpless and you'll be also helpless. 2 cancels, and you see which one cancels here. Cos theta plus alpha by 2 and cos theta plus alpha by 2 also cancels. So what I am left with is cos by sine, cot, understood, cos of the whole angle upon sine of the whole angle. So you get cot theta minus alpha by 2, which is equals to a. So theta minus alpha equals to 2 cot inverse a. But what is theta? Theta is sine inverse x, alpha is sine inverse y is equals to 2 cot inverse a. Differentiate, we get 1 under root of 1 minus x square minus 1 upon under root of 1 minus y square into dy by dx. And what is differentiation of cot inverse a? Cot inverse x, if you differentiate, is minus 1 upon 1 plus x square. So cot inverse a will be what? It's 0, it's a constant. Okay. So never make that mistake of writing this as minus 2 upon 1 plus a square, because a is anyway is a constant. So 2 cot inverse a, the whole thing is a constant, so 0. So you see your answer dy by dx is coming out to be 1 minus y square upon 1 minus x square whole under root. Okay, proved. Next question is 10th. A 1 minus cos theta and is y, and a theta minus sin theta is x. So this is parametric differentiation. You have to do dy by d theta and dx by d theta first. So you have y is equals to a 1 minus cos theta. So let's differentiate this. We get dy by d theta is equals to a sine theta. Then x equals to a theta minus sine theta. So x equals to a theta minus sine theta. So dx by d theta is a 1 minus cos theta. Understood? D theta by d theta is 1 and sine is cos. So dy by dx by parametric differentiation is dy by d theta upon dx by d theta. Dy by d theta is a sine theta. Dx by d theta is a 1 minus cos theta. So a cancels, we get sin theta upon 1 minus cos theta, which can be your answer for dy by dx. But we can simplify this further, so let's do that. Sin theta is what? 2 sin theta by 2 cos theta by 2 2 sine square theta by 2 is 1 minus cos theta. I think you can understand now. 2 and 2 cancels and one of the sine also cancels. What do you get? You get dy by dx as cos by sine, cot theta by 2. So now this is your first part done. The first part of the sum, find dy by dx and second derivative as well, d2y by dx2. So d2y by dx2, that is second derivative, differentiation of cot, you know, is minus cosec square theta by 2. Now theta by 2 with respect to x will be half, and because it is with respect to x, so d theta by dx should come here multiplied. This is the most important step. This thing, if you forget, you lose I think 2 out of, or maybe 3 out of 5. This will come as a 5 marker generally. So what happens? You put the d theta by dx from here. So you have minus cosec square theta by 2 into half into 1 upon a 1 minus cos theta y, because it's d theta by dx and this is dx by d theta, so reciprocal of that. Now 1 minus cos theta is 2 sin square theta by 2, so you can make it cosec to the power 4 theta by 2 upon 2a, etc. as your answer. But the main step is this. If you forget to do this, you're going to lose marks, I told you. Okay, 2 marks will be lost for sure. 11th, y equals to sine 2 sine inverse x. You have to prove this. Now most commonly occurring mistake is that you will start differentiating it here and you will be in great problem, because it will convert into a huge sum. Okay, so what you do, see this. We have y equals to sine 2 sine inverse x. And what we have to prove carries 1 minus y square, 1 minus x square in it. You know, the question will talk to you basically. You know, it will tell you like do the sum like this, and it is going to help you out. In fact, so that thing, this is telling me something here. It's 1 minus x square under root 1 upon under root 1 minus x square arises from where? From differentiation of sine inverse x, and 1 minus y square arises from differentiation of sine inverse y. I told you the question talks to you. So sine should be taken to the other side as sine inverse y. Everything now is totally, you know, the whole thing has changed now. You have to differentiate both sides. You get under root of 1 minus y square in the denominator into dy by dx, because you are differentiating with respect to x, not y. And this is 2 upon 1 minus x square under root. See what happened. That whole long sum got converted into a simple solution. Proved. This is what you have to get. Fine. So just shift sign to that side and differentiate. See always what you have to prove, and you can move accordingly. In 12th sum, put x as sine theta. This will convert into what? 5 sine theta plus 12 cos theta upon 13. And then if you recall from your inverse trigo video, which I made earlier, I have given similar kind of question there also. 5 sine theta plus 12 cos theta upon 13. 5 sine theta, I am doing only that much, not showing you the whole solution deliberately. Plus 12 cos theta upon 13. That upon 13, I will split with both. And we'll draw one right angle triangle here. This is not a rough work, you have to show this triangle. So outside was sine inverse, So just create your 5 as the base and 12 as the perpendicular. 13 will be your hypotenuse automatically. Take this angle as something, say alpha or something. Now see what happened. What is 5 by 13? Cos alpha. So you get sine theta cos alpha plus cos theta and sine alpha. Done. So this is sine theta plus alpha. Okay. And see what happened then. Then this becomes sine inverse, sine nullifies, you get theta plus alpha, but theta is sine inverse x. So sine inverse x plus alpha, differentiate. Alpha being a constant, the differentiation of alpha will be 0. Fine, so you get y equals to sine inverse sine theta plus alpha, which is theta plus alpha, but theta is sine inverse x from the assumption, and alpha is a constant. Huh? If this question is asked in inverse, I'll write alpha as tan inverse 12 by 5 from the triangle. But here it's not necessary to convert alpha because alpha is a constant, its derivative will become 0 anyway. So dy by dx is equals to 1 upon under root of 1 minus x square. The whole sum is actually sine inverse x to be differentiated. Now 13th question is about logarithmic differentiation. What happens when we have variable to the power variable? See, x to the power y to the power x, these are variable to the power variable, and there is a constant to the power constant in the other side I have taken. You can't differentiate this directly. You don't know how to differentiate variable to the power variable directly. There is no way basically. So what we do, we take u equals to x to the power y. Okay. And we differentiate this, so we apply log both sides, we can't differentiate directly. We get y log x. So 1 by u du by dx, because differentiation of log x is 1 upon x, and here it's product rule. So y as it is, differentiation of log x plus log x as it is into differentiation of y, which is dy by dx. So du by dx you got as u was x to the power y by x plus log x into dy by dx. Now we'll do v also. V, we'll take this as v, y to the power x. Same way, log v is equals to x log y. So 1 by v into dv by dx, differentiating both sides, x into 1 by y into dy by dx. Do you understand why I am putting dy by dx? Any implicit differentiation will be followed by dy by dx if the variable is not x and something else, that d by dx of that thing will happen. Okay. Log y is 1 upon y. Then by chain rule, y with respect to x is dy by dx plus log y as it is into 1. So we get dv by dx is equals to v. V goes up here. Getting me? Like this is cross multiplied, which is y to the power x upon y dy by dx plus log y. Now we have du by dx and dv by dx, and the question is now u plus v is equals to a to the power b. So if I differentiate this, I get du by dx plus dv by dx equals to differentiation of a constant 0. So that means this plus this should be 0. So just put these values, open it up and get dy by dx value separated by taking common and all. So that should be your answer, and what you have to prove is already given in the question here. So you should end up getting this result. Try. Y equals to e to the power x, a cos x plus b sin x. So y equals to e to the power x, a cos x plus b sin x. Prove this. So what comes in your mind is that you differentiate this once, then twice, and put everything here to cancel out and get the result as 0. Not a good method, guys. A very, very long method. In fact, again the question is talking to you that a cos x plus b sin x on second derivative na, repeats itself with a negative sign, Like if you differentiate sin x, na, it becomes cos x. You differentiate that again, you get minus sin x. So see, and same similar thing with cos also. So they come back with a negative sign, is the hint here. And what we do, that because of this reason, I'll take e to the power x to the other side. I'll make it y into e to the power minus x equals to a cos x plus b sin x. These things you can't find everywhere, these methods. So stick to the rules. If you practice well, you'll be habituated with these kind of nice methods. Now differentiate both sides. We get e to the power minus x as it is into y. So e to the power minus x as it is, then differentiation of y, dy by dx, and minus e to the power minus x into y, doing product rule. Like e to the power minus x as it is, y differentiated. Now e to the power minus x differentiated and y as it is equals to minus a sin x plus b cos x. So you see, e to the power minus x is common, and I am left with dy by dx minus y is equals to minus a sin x plus b cos x. I think it's already talking to you now. Let's see. So again, e to the power minus x as it is, and second derivative d2y by dx to minus dy by dx minus e to the power minus x into dy by dx minus y equals to minus a cos x minus b sin x. So you see, e to the power minus x is common again, and what I am getting inside is d2y by dx2 minus dy by dx minus dy by dx. So minus 2 dy by dx plus y, fine, plus y is equals to minus sign common. So what is this? This is nothing but from equation 1 y into e to the power minus x, and there is a minus sign already. See, this e to the power minus x and this e to the power minus x cancels. Rest is at your service, man. The result 2 dy by dx plus 2y equals to 0. So see how short the solution is if you use your brain. And try to use your brain as much as possible. It is good for you. Next question, this 15th, y equals to e to the power a cos inverse x. Y is equals to e to the power a cos inverse x. So we can make it log y equals to a cos inverse x into log e, which is 1. So log y. Why I have applied log? To just make it a little simple, not necessary. You can directly do it also. Now see, 1 by y dy by dx is minus a upon 1 minus x square under root differentiation of cos inverse x is negative, Now I have a process for this. And how to identify? Your second derivative is multiplied with something. You apply this process of mine which I am about to explain. No root, no denominator, I call it. No root, no denominator. Means there shouldn't be any denominator in my sum. There shouldn't be any root in my sum. Denominators I'll cross multiply. Root I'll square both sides. So I'll square both sides and I'll cross multiply. I'll get 1 minus x square dy by dx whole square, getting me, is equals to negative squared becomes positive a square y square. Remove the roots and cross multiply to get the denominators removed as well. Now differentiate both sides. 1 minus x square as it is into 2 dy by dx into second derivative d2y by dx2 minus 1 minus x square differentiated minus 2x dy by dx whole square should result in a square, and y square is 2y dy by dx. Now from the whole thing now you see 2 dy by dx, 2 dy by dx and 2 dy by dx cancels out. What I am left with is 1 minus x square d2y by dx2 minus x dy by dx minus a square y is equal to 0. This shifted to that side. Now let's see what we have to prove. Proved. Comes automatically. In this process if you apply, it comes automatically. I have observed that I don't even have to see that what is to be proved. Sometimes they give wrong equations to be proved. You can rectify their mistake as well doing this. So no root, no roots, no denominator. Can be pretty useful. 16th plus plus tells you that there is no trick. Simply differentiate and you will get this result. Simply differentiate, carry on. 17th, same thing. There is no trick associated. Simply differentiate and you will get the result directly. Only thing that you have to know is the formula of cos x, which is 1 minus tan square x by 2 upon 1 plus tan square x by 2. Maybe this will be used. So just differentiate and get it. Coming to the 18th one. Base changing formula. Change of base in logarithm. If you have log of base a b, you can write that as log b by log a, and your base can be anything. So e, because e is only that we can differentiate. And further we know log m by n is log m minus log n. So these are your tools to handle this sum. Why Because first you'll write y is equals to log of base 7 log x by log 7. The base is e. Okay. I used base changing formula here. This becomes log base 7 log x minus log base 7 log 7. Now I don't have to worry about this part because log 7 is a constant. So log of base 7 log 7 is fully a constant. Only this part I have to further apply the formula. So that's log of log x upon log 7 minus, now this whole thing is a constant. So writing it as k, or you can write the whole thing as it is, but its differentiation will go. Now if I differentiate, it will be log x. First of all, 1 upon log 7 is a constant, is kept outside, and then I have log x. So 1 upon log x into 1 upon x following the chain rule and minus 0. So your answer is 1 by log 7 log x into 1 by x.